two projects. In this video, we are going to explain about the project, which is a deep learning based sentiment analysis approach for online product ranking with probabilistic linguistic term sets. Introduction of the project. The exponential growth of e commerce has led to an overwhelming abundance of online products, making it challenging for consumers to make informed decisions. In this context, product ranking play a crucial role in guiding users towards desirable choices. Traditional ranking algorithms often rely on objective factors, neglecting the subjective aspect of user satisfaction. This project introduces a novel approach that leverages deep learning techniques to incorporate sentiment analysis into online product ranking. The primary objective of this project is to enhance the accuracy and relevance of online product ranking by integrating sentiment analysis. By understanding and analyzing the sentiments expressed in user reviews, the proposed deep learning model aims to provide a more comprehensive and user centric evaluation of products. This approach goes beyond conventional ranking methods by tapping into the emotional and qualitative aspects of user experiences. Sentiment analysis has gained significant attention in recent years due to its potential to uncover valuable insights from the unstructured data. Applying sentiment analysis to online product ranking not only benefits consumers by offering more nuanced insights into product quality, but also provides businesses with actionable feedback for improving their products and services. The project aims to bridge the gap between user feedback and product ranking, ultimately leading to more informed and satisfactory purchasing decisions. The project employs state of the art deep learning techniques to develop a robust sentiment analysis model. The model is trained on diverse dataset of user reviews, learning to recognize and categorize sentiments expressed in the text. The sentiment scores obtained are then integrated into the existing product ranking algorithm, creating a hybrid approach that combines both objective and subjective evaluations. The anticipated outcomes of this project include a more accurate and user oriented online product ranking system. By considering user sentiments, the model aims to provide personalized recommendations that align with the individual's preferences and expectations. Objective of the project. The goal of the project is to develop and implement advanced sentiment analysis techniques using deep learning models to improve the accuracy and effectiveness of sentiment predictions on the provided dataset. The objective is to build diverse deep learning models including LSTM, LSTM with GRU, CAR CNN, text RNN, text CNN, sequence to sequence, BERT, and fast text CNN to understand their capabilities in handling sentiment analysis tasks. The project aims to implement the sentiment analysis model to predict the class labels, specifically identifying whether the sentiment in the input text is positive, negative, or neutral. The objective is to provide a comprehensive understanding of the sentiments expressed in user generated content. The objective here is to employ standard error metrics including accuracy, precision, recall, and FN score to rigorously assess the performance of the developed sentiment analysis models. This aim to quantitatively measure the model's effectiveness in classifying sentiments and identify areas for potential improvement. The goal is to identify and highlight the key stakeholders who will benefit from the project's outcomes. This include e-commerce platforms, businesses relying on user feedback, and consumers seeking more informed and nuanced product recommendations. The project aims to enhance user experience, guide purchasing decisions, and provide valuable insights for businesses to improve their products and services. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. And the hardware requirements which are needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary libraries and packages that are required for the project. We imported pandas for data manipulation, NLTK for natural language processing, scikit-learn for machine learning algorithms, NumPy for numerical operations, matplotlib and seaborn for data visualization, keras and TensorFlow for deep learning. Coming to the next step, which is exploring the dataset. Here we explore the sentiment dataset to understand its structure, features, and sentiment labels. This step includes loading the dataset, checking for missing values, and gaining insights into the distribution of sentiment classes. Coming to visualization, here We have sample outcome, which is displaying a sample outcome which allows a quick look at the dataset to understand the format of the textual data and corresponding sentiment labels. Here, word cloud refers to visualizing. A word cloud provides a graphical representation of the most frequently occurring word in the dataset, aiding in understanding the key features. The next step is data processing. Here we have eliminated irrelevant characters and URLs that may not contribute to sentiment analysis. We have removed punctuations, which helps in cleaning the text by removing unnecessary punctuations. We also removed stop words, which eliminates common words that don't contribute much to the sentiment. Normalization of the data is standardizing the text data to a consistent format. We have tokenized and lemmatized, which is breaking down the sentences into individual words and reducing them to their base or the root form. We also vectorize the text, which is converting text data into numerical form, which is essential for machine learning models. The next step is tokenization. We have did tokenization using Keras Tokenizer, which utilizes Keras library for tokenization. It is a crucial step in preparing text data for deep learning models. Keras Tokenizer is a text processing tool in the Keras library that converts sequences of text into numerical tokens, facilitating input preparation for deep learning models by assigning a unique integer to each word in the dataset. We also used BERT tokenizer, which applies BERT bidirectional encoder representations from the transformer tokenizer, especially useful for advanced natural language processing tasks like BERT. BERT tokenizer is specifically designed for BERT-based models and breaks down input text into subwords, enabling bidirectional context understanding and capturing intricate linguistic nuances for advanced natural language processing tasks. The next step is feature selection. Here we have selected relevant features for model training, which is optimizing computational efficiency and focusing on meaningful information. Splitting the data into train and test. Here, we divide the dataset into training and testing sets, which is ensuring models evaluation, which is performed on unseen data. Building the model. Here we develop the architecture of the sentiment analysis model. The choice of the model depends on the project's goal and the dataset characteristics. This step involves defining the layers, structure, and the parameters of the model. The next step is training the model. Here we train the model on the training dataset, which enables it to learn patterns and association between input text and sentiment labels. The next step is Flask framework with SQLite for sign up and sign in. Here we implement a Flask web framework with SQLite for user authentication, enabling secure sign up and sign in functionalities. Coming to user input, here we allow users to input text for sentiment prediction. The given input is pre-processed. Here we prepare user input by applying the same pre-processing steps as the training data to ensure consistency. The next step is train model is used for prediction. Here we use pre-trained sentiment analysis model to predict the sentiment of the user input. LDA model for topic modeling. Here we applied latent dirichlet allocation for topic modeling, which extracts thematic content from the user input. The last step is final outcome is displayed through frontend. Here we present the final sentiment prediction and the topic modeling results to the user through a user-friendly frontend, enhancing user interaction and understanding the model's output. Now we will know what are the algorithms used in the project. The first algorithm is CAR-CNN, which refers to Character Level Convolutional Neural Network. Character Level Convolutional Neural Network is a specialized deep learning architecture designed for visual data processing, employing convolution layers to automatically learn hierarchical features and spatial patterns. CNNs are widely used in computer vision tasks such as image recognition due to their ability to capture and leverage local features within the input data. Now, coming to CAR CNN, it processes text at the character level utilizing convolutional layers to capture patterns and relationship between characters. It is effective in understanding the sequential nature of the characters in the text data. KRCNN is beneficial when dealing with the short and noisy text as it can capture character level features, helping in sentiment analysis where subtle nuances will be present at the character level. Coming to text RNN, which is RNN refers to recurrent neural network. First, we will know what is RNN. It is a type of neural network architecture designed for sequential data processing, featuring recurrent connections that allow the network to maintain memory of the past inputs. RNNs are suitable for tasks where temporal dependencies and the context within sequential data are crucial, such as natural language processing and time series analysis. Coming to text RNN, it is a type of recurrent neural network designed for capturing sequential data, processing input data in step-by-step manner while maintaining memory of past steps. It is suitable for tasks where context and sequence are crucial. Text RNN is utilized to capture sequential dependencies in the textual data, making it effective for sentiment analysis where the order of the words can significantly impact the overall sentiment. Coming to text CNN, text CNN applies convolutional operations to text data, extracting hierarchical features through various convolutional layers. It is particularly useful for capturing local patterns and identifying significant textual features. It is employed to capture local features and relationship between words, contributing to the sentiment analysis process by identifying relevant patterns in the textual data. Coming to sequence neural network, it is a type of neural network architecture specifically crafted for processing sequences of the data, where the model takes in a sequence of inputs and produces a sequence of outputs. This architecture is commonly used in tasks like machine translation, summarization, and other applications involving input and output sequences of varying lengths. Sequence to sequence is applied for tasks that involve generating sequences, potentially useful in aspects of sentiment analysis that require understanding the sequential flow of the sentiments within longer text. Coming to BERT, which is bidirectional encoder representations from the transformers, it is a transformer based language representation model designed to capture bidirectional context information from the input text, making it effective for understanding contextual relationship between words. BERT is used for advanced natural language processing tasks, offering a deeper understanding of contextual nuances in the sentimental analysis, which is crucial for accurate prediction. The last algorithm is fast text CNN. Fast text is an embedding technique that represents words as vectors. Combining fast text with CNN allows capturing complex hierarchical features in the text data through convolutional layers. It is beneficial for its ability to represent words as vectors and capture hierarchical features, contributing to the overall understanding of the sentiment patterns in the given text data. As an extension, we applied an hybrid method that combines the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built front-end using Flash framework for user testing with the user authentication. We used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate all the classification models of the project. So here we have the performance comparison graphs for all the models built in the project. This is accuracy comparison graph where x-axis represents accuracy score for each algorithm built in the project and y-axis represents all the algorithm names. Similarly, we will have for other graphs also. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall score comparison graph. Recall is also known as sensitivity or true positive rate. It measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is FN score comparison graph. FN score is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. In this folder, we have the datasets which will be used for training the models. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign up file. This file is a database file used to store the user information. Now, to execute the project, we have to copy the path of the code folder from the address bar of the File Explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. Here we can observe that current directory is changed to the code folder's path. Here we need to type the command python space app.py to compile app.py file. And now we need to click on enter. This will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which will be the localhost and the port unless configured differently. This is the localhost and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First, we need to click on that. Here we can see that all the details need to be entered if you are signing up newly. I have already signed up and I have an account in it, so we will directly sign in. For that, click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a text box wherein we need to give the input message. Based on the given input message, we will get the sentiment prediction. So here I'm entering the other message. Now we will click on predict. Here we got the prediction as the product review is positive, which means the application has predicted that this particular message, which is the product review, belongs to positive sentiment. And the topic for the paragraph is most dependent upon these words. Now we will give other review. Click on prediction. I have given the message here. Now we will click on predict. Here we got the prediction as the product review is neutral, which means this particular message belongs to the neutral sentiment. And the topic for the paragraph is most dependent upon these words. Now we will try giving the other message. Click on prediction. I have given the message here. Now we will click on predict. Here we got the prediction as the product review is negative, which means this particular message belongs to the negative sentiment. And the topic for the paragraph is most dependent upon these words. Now click on sign out. In this way, if we enter the message, which is the product review, to the system, then the system will predict which type of sentiment to the message belongs to, which is positive, negative, or neutral. By this, users can take the decisions to purchase the product. Conclusion of the project. The project successfully implemented and evaluated a diverse set of advanced sentiment analysis techniques, including CAD CNN, text RNN, text CNN, sequence to sequence, BERT, and fast text CNN, showcasing a comprehensive exploration of the state of the art models. The project systematically explored various deep learning models, each designed to capture unique aspects of the sentiment in the textual data. Evaluation metrics including accuracy, precision, recall, and FN score were employed to rigorously assess and compare the performance of these models. The extension of the project involved applying ensemble methods to combine predictions from multiple individual models, demonstrating an effort to enhance the robustness and accuracy of the sentiment predictions. The integration of the sentiment analysis models into a Flask framework with SQLite for user sign-up and sign-in facilitated a user-friendly interface. Users can input text for sentiment prediction, and the final outcomes, along with the LDA-based topic modeling results, are effectively displayed through the front end, providing an accessible and interactive platform. The project outcomes hold significant value for various stakeholders, including e-commerce platforms, businesses relying on user feedback, and consumers seeking more informed and nuanced product recommendations. By enhancing user experience, guiding purchasing decisions, and providing valuable insights, the project has potential to positively impact both user businesses and end users in the realm of sentiment analysis.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Project's YouTube channel and subscribe.